Alright, so this lesson is all about trig and horizontal transformations. Our goal by the end of this video is that we're going to be able to determine the periods of trig functions, and we're going to be able to graph trig functions with horizontal transformations. So first of all, let's think about the periods of these functions here. Now I notice this graph looks familiar. This is the sine graph. This is cosine. This graph here, the midpoint is at the origin, so that is tangent. This graph here, the midpoint is right here, which is at about pi/2. It is in decimal form. So this is cotangent. Okay, so the period. It's a distance in which we see something that is being copy and pasted throughout the entire graph. So for sine, it would be this part here, 0 to 2 pi. 2 pi is about 6.28. So this distance is one period, and that distance, 0 to 2 pi, is 2 pi. Similarly, with cosine, we see that this curve is repeated throughout the theta axis, and that distance from 0 to 2 pi is 2 pi as well. So sine and cosine, their periods are 2 pi. Similarly for secant and cosecant. Now for tangent and cotangent, it's a little bit different. So tangent, we see that one period would be this curve here, and it's copy and pasted to the left and right. And we know that the vertical asymptotes for this tangent graph is negative pi/2 and pi/2. If we were to find that in decimals, pi/2 is about 1.57, so it's in between 1 and 2. So this distance, we got to think about what this distance is. So I know from here to here, from 0 to pi/2, that distance is pi/2. So then the same thing from negative pi/2 to 0, that distance would be pi/2 as well. So pi/2 plus pi/2, the period for tangent is pi. And same thing for cotangent. This curve here is copy and pasted throughout the x-axis. We see another repetition here. And we know that cotangent's vertical asymptotes are here and here. That's 0. And here would be pi, about 3.14 decimal. So then the distance from 0 to pi is pi. So the periods for sine, cosine, and similarly secant and cosecant is 2 pi. And for tangent and cotangent, their periods are pi. Okay, now let's look at horizontal stretches and compression. So we want to look at a trig function in which theta has a coefficient b in front of it. What does that b do? I have our sine of a a times x, and we want to know what does that coefficient a do to the graph. So here's our slider. When a is 1, we have our basic sine of graph, or sine graph. If we increase a all the way to 8, it squishes the sine graph, squishes it horizontally. So that would be a horizontal compression. Let's look at what happens when the constant is less than 1. So we're back to 1, less than 1. It really stretches it out. Stretches it out when it's less than 1. So we saw this constant here. When that changes, if it's greater than 1, it really compresses the sine graph, and if it's less than 1, it stretches it out a lot. Say b was 2. We want to look at y is sine of 2 theta. What we saw earlier on GeoGebra, so 2 is greater than 1, it's gonna compress the sine graph horizontally. So it squishes it so that instead of making one rotation in between 0 and 2 pi, it actually does 2 in between 0 and 2 pi. So that means that its new period, which is, again is just one copy of it, is in between 0 and pi. So it changes the period to pi. Now if we notice, if we take our normal period, we know that the normal period is 2 pi. If we divide it by our constant here, our b value 2 pi divided by 2, we get pi. So that idea is going to give us this formula. The period is going to be 2 pi over b. We can check with this. Our period is 2 pi, the normal period, without any stretches or compressions. We divide it by our b value, in this case 2. 2 pi divided by 2 is our new period, pi. So it compresses the sine graph so that one period is now shorter, just pi. Okay, so let's look at another example. Oh. Okay, so our b value now is 1/2. I'll make a note of that. This is our b. So in order to find the period for this, we would take the normal period for cosine, which is 2 pi, divide it by b. So it's 2 pi over 1/2. To simplify this, we can multiply by 2, top and bottom. Those 2's cancel, and we're left with 4 pi. So instead of one period of cosine being within 2 pi, it stretches all the way to 4 pi. So cosine starts at the max, goes to the midline, min, midline, max. So it stretches cosine so that one period is now 4 pi. It's twice as big. Okay, So, how do we determine the period? Well, if we are looking at y equals sine of b times theta, or cosine, or secant, or cosecant, because they all have a period of 2 pi, the new period, either squished or stretched out, is going to be p equals 2 pi divided by that b value. If y is equal to tangent of b theta, or cotangent, then the new period is going to be pi over b, because pi is the normal period for tangent and cotangent, as we saw earlier. So for these 4 trig functions, sine, cosine, secant, cosecant, to find the period, it's 2 pi over b. For tan and cotangent, to find the period, it's just pi over b. Okay, so now let's look at some horizontal shifts. So horizontal shifts, what if we had a trig function where we were adding something on the inside of the argument? We were adding something to theta inside the parentheses. So pull up GeoGebra again. We've got sine of x plus h and a slider for the h value. Let's see what happens when we change h. So if h is positive, we see that it's moving to the left. Go back to 0. If h is negative, we see that it's shifting to the right. Okay. So we noticed that h is the horizontal shift, either left or right. And we noticed a couple things. If h is positive, then we shift to the left. And if h is negative, then we're shifting to the right. So let's look at a little example. Say we were looking at y equals sine of theta minus pi over 2. So usually sine would start at 0. This is pi, 2 pi. Usually sine would start at 0, but now we have this horizontal shift, pi over 2, and it's negative, so we're going to shift to the right. So instead of starting at 0, we're going to start at pi over 2, since we're moving pi over 2 to the right. So we start at the midline, max, midline, min, and midline again. This would be 5 pi over 2. And we sketch our graph. And we can go this way as well. So there's our sine graph. Shifted pi over 2 to the right. Okay. So now we have this general form for trig equations, where we have all of the transformations in there. We got reflections, vertical horizontal shifts, vertical horizontal compressions or stretches. So let's define all of the parts for this equation here. A, as we saw before, we know that's that vertical stretch or compression, or it's the amplitude. And if A is negative, we flip it vertically. B, we saw is the horizontal stretch of compression, so it can either squeeze it or stretch it, and we can use B to find the period. H, we saw as the horizontal shift, so it shifts it to the left or to the right. And K, we know from earlier, is the vertical shift, shifts it up or down, and K is the midline as well. So we have the steps for graphing here, for graphing the general form. First, we determine the period. For sine, cosine, secant, or cosecant, we know that normally the period is 2 pi. So in order to find the new period, we're going to use this formula. The period equals 2 pi over b. For tangent and cotangent, normally the period is pi. So instead of 2 pi over b, we're going to use pi over b. And then we're going to determine the step. Now you may wonder what is the step? And step is going to be that period over 4. So we're going to do examples where we use it, but very quickly, the sine graph, for example, it's useful to know what these tick marks are going to be. We want to know these values so that we can see how the graph has shifted. So notice the period for this normal sine graph is 2 pi, and we divided it into 4 equal parts. So we know what the tick marks are: pi over 2 pi, 3 pi over 2, 2 pi. So if we take our period and divide it into 4 equal parts, then that is how we get those tick marks, and I call it step. So for example, if we were to find the step, if we were to find the step for this normal sine function, we know the period is 2 pi, and we divide it by 4, and we can simplify that, and that's pi over 2. And that is what we're increasing by every time. We start with pi over 2, 1 pi over 2, then 2 pi over 2, which is pi, then 3 pi over 2, then 4 pi over 2, which is 2 pi. So that's what that step is. Helps us determine how much we're increasing by on the theta axis. So after we determine the step, we identify all the transformations, and then finally we graph. We're going to do some examples. Okay, so first step is we need to determine the period. Well, actually read the question first. We're going to graph each function and state the period. Okay, cool. So our first step, determine the period. For sine, cosine, secant, cosecant, we're going to use the period is 2 pi over b, since this is sine. So period is going to be 2 pi over b. Let me identify the parts here. So this is b, and this is a. Okay, so 2 pi over b is going to be 2 pi over 1/2. We can simplify this by multiplying 2 top and bottom, and that's going to be 4 pi. Those cancel. Over 1, or just 4 pi. Okay, cool. So our new period is 4 pi. It's stretching out the sine function. Instead of being in between 0 and 2 pi, it's going to be in between 0 and 4 pi. Now we determine our step. It's the period divided into 4 equal parts. So that's 4 pi divided by 4 equals pi. Okay, so our steps are going to go by pi. So pi, 2 pi, 3 pi, Notice by the time we reach the fourth step, that's the end of the period for pi. Okay, so we notice plus 0, that's our k value. If we don't see anything added to it, then we're not shifting up or down. Our midline is still going to be at 0. Midline at 0. And then we use our amplitude, which is 2. We know we're going to go up 2 and down 2. Okay, and its sign, we know we start at the midline, max, midline, minimum, midline. And there's our function. All right, let's look at number 2. Okay, so I see this is our A, this is our B, and here we have our H, the horizontal shift. So first, we determine the period. It's cosine, so we're going to use 2 pi over b. B is 2. So the new period is going to be pi. And then from here we determine our step, which is our period, divided into 4 equal parts. Our period is pi. So our step, we're going to go by pi over 4 for each tick mark. Okay, cool. So we notice we don't have any vertical shifts. Our midline is still at 0. We're not moving up or down. So our period, we should be done at pi. And our each tick mark is going to be pi over 4. So start pi over 4, and then 2 pi over 4, which reduces to pi over 2, and then 3 pi over 4, and then 4 pi over 4, which is pi. Our amplitude is still 1. So there's our max and min. And finally, we have this h to worry about. We are shifting. H is negative pi over 4, so we're going to shift to the right by pi over 4. So instead of starting at 0, we're going to start at pi over 4. So I'll just make a line here to remind ourselves that we're starting at pi over 4, not 0. Okay, cool. So we're starting at pi over 4. We know that cosine, it starts at the maximum, but we're flipping it, so we're going to start at the minimum. So minimum, midline, maximum, midline, and then minimum again. This would be at 5 pi over 4. And then we sketch. And there's our lovely cosine graph. Okay, so we've got secant pi over 4 of theta plus 2 plus 1. So our amplitude is, or our A value is 1. This is our B. This is our H, and this is our K, or midline. Since it's secant, we're going to be looking at cosine. Okay, so let's look at all these parts here. Our new midline is at 1. We need to determine the period. So the period is 2 pi over b, which is 2 pi over 4, multiply by 4 top and bottom, and these 4 cancel, we get 8 pi over pi, the pi's cancel, we get 8. So our period is 8, then our step, which is the period divided into 4 parts, is 8 over 4, which is 2. So we're going to go 2, 4, 6, 8. And that should be 1 period. So our midline is at 1. Our amplitude is still 1, so we go up 1 and down 1. And we finally, our horizontal shift is positive 2, so that means we're going to move to the left by 2. So this is our new starting point. We're moving everything to the left by 2. Okay. So since what we really want to graph is secant, I'm going to make this cosine graph dotted. So we know that cosine starts at the max. And remember, we're now starting at -2 because we shifted it to the left. So we start at max, then min, or midline, min, midline, max. I'm going to make that dotted. And of course, we can continue like this. Now we sketch the vertical asymptotes. We know that the vertical asymptotes are where cosine crosses the midline. So crosses the midline here, here, and here. Oh, should have used a different color. Blue. These are the vertical asymptotes. And now we can sketch the secant graph. So they touch at the peaks and valleys and don't cross the vertical asymptotes. So there's our secant graph. All right, number 4, we're looking at -1/2 cosecant of 3 times theta minus pi over 3 minus 2. It has all of the parts in there. So this is our A. We're going to flip because it's negative. This is our B. And this is our horizontal shift. This is our vertical shift or midline. Okay, since it's cosecant, we're going to look at reciprocal of cosecant is sine. Okay, let's determine the period. So we're looking at cosecant, so 2 pi over b is 2 pi, b is 3. So the period is 2 pi over 3. So our step is the period divided into 4 parts, which is 2 pi over 3 over 4, which is the same as 2 pi over 3 times 1/4. We can simplify, divide by 2 is 1, divide by 2 is 2. So it's pi over 3 times 2, 6. So our step is going to be pi over 6. Okay, so there's a lot to consider here. Okay, so our step is pi over 6. Then we go to 2 pi over 6, simplify it, pi over 3. Then 3 pi over 6, simplify that, pi over 2. And then 4 pi over 6, we simplify that, it's going to be 2 pi over 3. We see that our midline is at 2, or negative 2. Our max, we're going to go up 1/2 and down 1/2. Up 1/2 and down 1/2. This is our midline at negative 2. And finally, we are shifting by negative pi over 3. So we're going to shift to the right. Since h is negative, we're going to shift to the right by pi over 3. So instead of starting at 0, we're going to start at pi over 3. Or we can think of it as we're moving everything to the right by 2 tick marks. 2 tick marks. So we start 2 over. Now we're looking at sine, but it's negative. So we start at the midline. Instead of going up, we're reflecting it vertically, so we're going to go down to the min, back to the midline, max, and then midline again. Going to make that dotted. We sketch in our vertical asymptotes where we cross the midline here, here, and here. And of course we could continue this graph like that. And we know that cosecant and sine would touch at the peaks and valleys, these 3 spots here, and we're not crossing the vertical asymptotes, making these U shapes. And that's our graph there. All right, final 2 problems. We're looking at tangent and cotangent. So we got to state the period. Since we're looking at tangent this time, we're not going to use 2 pi over b. We're going to use pi over b. Oh, let me identify the parts. This is A, and this is B. And that's our K. So we're not shifting it up or down by anything. It's still at 0. Okay, so our period. Pi over b is pi over 1/2. That's our b value. So we multiply by 2 top and bottom. 2's cancel. We get 2 pi. Okay, so we're stretching it out. Instead of only being between, or a period only being pi, it's now 2 pi. So we're stretching it out. And our step is going to be the period divided into 4 parts. So 2 pi over 4, which when we simplify it is pi halves. Okay. Now we know for tangent, the midpoint is at the origin. So usually we would go from the origin 2 tick marks to the right and 2 tick marks to the left. And these tick marks, or these steps, is pi over 2. So this will be pi over 2, this will be pi, and to the left would be negative pi over 2 and negative 2 pi over 2, or negative pi. And we can sketch in our vertical asymptotes. We know that it's at the first and fifth values, and negative pi and pi. And sketch or plot our 3 points. So the middle point stays the same. We're not shifting it by anything. Tangent goes up from left to right. And we see that A is 2. So instead of at negative pi over 2 being negative 2 or negative 1, it's going to be negative 2. So we're going to go down 2 and up 2. So at negative pi over 2, we're at negative 2. And pi over 2, we're at positive 2. The tangent graph I struggle with. Whoa, there it is. All right. So there's our tangent graph. All right, number 6, period. It's not going to be 2 pi over b, pi over b, because we're looking at cotangent here. So our b is 2. Oh, let me circle those. Don't want to forget. Here is our a. We're flipping it because it's negative. Here's our b. Here's our horizontal shift. And that's our k, where the middle point would be. So no change there. Okay, so our new period is pi over 2. So we're squishing it. Instead of being pi, it's now pi over 2. And the step is the period divided by 4. So pi over 2 divided by 4. We can multiply by 2 top and bottom. So we get pi over 4 times 2 is 8. So now we graph. Put in our steps. So 1 pi over 8, 2 pi over 8, or simplified pi over 4, 3 pi over 8, and 4 pi over 8. When we simplify, it goes to pi over 2. And we know the midpoint would usually be at the third tick mark, which would be here. So we would usually start at the third angle, but we are shifting by negative pi over 4, so we're going to move to the right by pi over 4. So notice pi over 4 is 2 tick marks. 2 tick marks. So we're going to move to the right 1, 2 tick marks, which would be here. So this is where we're starting from, or this is where our middle point is going to be. So I'll add 2 more 2 more tick marks here. That would be 5 pi over 8 and 6 pi over 8, which is 3 pi over 4 when simplified. Okay, so our midpoint is now going to be at pi over 2. We're not moving it up or down, so it's going to stay at 0. Y equals 0. We know that cotangent vertical asymptotes is 2 to the left, 2 to the right. We know cotangent usually goes down from left to right, but we're flipping it because of this negative a value. So we're going to go up from left to right. And it's still, notice the a value is -1. So no vertical stretch there. So we're going to go up from left to right. So at 3 pi over 8, we're -1. At 5 pi over 8, +1. And wow, there's our graph. A little bit messy, but there it is. All the parts to it. Okay, finally, we got practice problems, graph each function, and state the period. Thanks for watching.